Hello and welcome. In this video, I'll be going over the exercises to the intermediate programming. So for this first problem, what we're asked to do is create a function that takes any string as its input and which outputs an output string that is composed only of the A, T, G, and C characters that were present in the input string. So the way we go about doing this is we'll have a definition block of code here. So whenever we're making a function, we say def and give the function a name and supply an input variable here. And of course, this variable is going to take on the values, this is going to take on the value that's supplied by the user. So when the user calls this function, in this case here, I demonstrate with this sequence, they'll supply their own user-defined sequence. And so that then becomes a variable in the function. So here we'll use input string, but we're not explicitly defining it here in the function because it's going to be defined later when it's called. So what this does then is it goes through each character in this input string. And then, of course, we have this empty string here that is our output string. And the idea is it's going to be grown progressively as we go through the characters in the input. And each time we go through a character in the input, we'll just check, is it one of these, A, T, G, or C? And one way you could do this is by doing an if statement and then adding a bunch of elif blocks. That works. That would be totally fine for the different possibilities for A, T, G, and C. A shortcut, though, which I'll just show you, is that you can add or logic to this condition. So we just, Python will recognize what we mean by this. We say or, and then just provide another condition. So we'll check, is character equal to A, or character equal to T, or G, or C. And if any of those is satisfied, then this overall kind of compound condition is satisfied. And then that will let us increment our counter. Or excuse me, that will let us append our character to the growing string. So we have this empty string, and then the character is added to it if this condition is satisfied. And then at the very end, an important part is to return something. So not all functions necessarily have to do this, but many of them do. We supply we kind of export some data from inside the function to the outside world. And this lets us, if we want to, say, we could call this my sequence. This lets us assign the output to a variable. And so now we have a sequence which we could call just check. And now it has this value that was produced from running the function. And if we don't supply this return statement, then nothing will get assigned. So that's the first one. How about the second one? So in the second one, use nested for loops to count how many pixels in this cry2 image have a pixel value greater than 0.8. And the idea here is, so if we can just show this image, right? T and show, what's it called, our image. So we have this picture here of a cell, and some of these pixels, their values are, so all the pixels in this image have values from 0 to 1. So this variable here that we've created is simply a matrix of pixels and their values, with one element per pixel, and the values correspond to the brightnesses of these pixels. So they have different values, you can see, and our program is just going to check which ones have values greater than 0.8. So this is how you could do that. So you create a counter, initialize it, set it to 0. And as we suggested in the prompt, what you can do is use 2 for loops to loop through the rows and columns in the matrix. And so essentially what we have to do is get indices for both the rows and columns. So we'll have a loop that goes through each row from and it's going to use this range. So it will be taking on the values of the rows, so just the position. So we'll just be counting, right, numbers from 0, 1, 2, 3, 4, and so on until the last row. So what is the last row? So to figure that out, we have to think, if it's rows, then we want it to be like, like the height of the image, right? We want to go through all rows from top to bottom, basically. And so one way we could get the height is using an indexing scheme here to fetch just one column from the matrix. And that should give us the height. The length of that column should be the same as the height of the image. So one way to get a single column is to use the RC Roman Centurion indexing scheme and supply a colon for all rows and 0 for the 0th column. So this would get us a column, and then we put that in our length function, and then that will get us the number of rows, the length of the column. And then we do kind of the converse here to just get the number of columns. And of course, if we're looping from within a row, they're not really columns anymore. It's more just like items in the row, but they correspond to the columns. And so we do the converse. So then we want to get the length, the size of a single row. So then that's going to be row 0, all columns. And then finally, inside we have our conditional statement. It's just checking, is the pixel, our image, the matrix at this position, row whatever, and column whatever, is that equal to, or is that greater than 0.8? And if so, then we increment our counter by 1. Problem 3. Complete what remains of the microarray problem. Produce a matrix with just green values in each spot. Use a pixel to microarray spacing conversion factor of 25 as we did above. What is the green value in the microarray spot at row 8 and column 12, assuming the numbering includes a row 0 and column 0? So for this one, we have this image, right? It's a color image, an RGB image of a microarray. And so, of course, the key trick here is that there's a couple things going on, right? We have this image is itself a matrix, but what we want is a matrix that corresponds to the spots, the microarray spots, so that has smaller dimensions than this image actually has. And so this code here that we supplied, change this back, the code that we supplied is going to do that. It will, according to the space between spots, go through and fetch pixels from each spot, and it's simply multiplying the increment here. Yeah, so we know we have, like, say eight rows here. It's multiplying it by the spacing between each spot, which is uniform. So we know that if we want the the third row, then it would just be 3 times that spacing to get to that pixel, and then we'll fetch the item that's stored in that location. And so the indexing is similar to the other matrix problems, right? We want to fetch the row, and we also want to fetch the column. But then there's one catch, which is that the data stored in the pixel is not a single value. It's actually 4 values. It's a RGB alpha values. And alpha, of course, is just the transparency. And so what this script has done is it's gone through and fetched the first of each of those pixel lists, the first item in it, which is always going to be the red value. So item 0 here. And then added that to a matrix that's being grown. And sorry, this should be red matrix if we're starting from the initial point. So the first one fetches the red data, and then the problem asks us to get the green one. So I'll just go back, rename it. So we want the green one instead. And the way we get that is instead of fetching item 0 from each pixel, we fetch item 1 because it's RGB alpha. And then we want to look up row 8 and column 12. And so here we have our solution. And if we check row 8, column 12, it's this pixel right here. Likewise, if we check the actual array, it's a bit tricky. 0, 1, 2, 3, 4, 5, 6, 7, 8. And it's this one right here. This is the 12th column. Okay. And the optional challenge problem asked us to make a histogram of the values, the brightnesses in this Cry2 image. So going back to that image. And so this matrix, it's full of different brightness pixels. And this one is just grayscale, right? So we don't have to worry about RGB. Well, it's colored here, but this is false coloring, right? This is just to visualize the range of colors, but it's being applied to just this matrix, which is actually a grayscale image, or a gray a matrix with simply values in it from 0 to 1 each. And we can see, like, for instance, that the majority of these values are going to be really low, right, in the dark range, close to 0. But then there's going to be a range of intermediate pixel values as well, and a few spots here that are really high. And so we just want to create a histogram. And one way we can do that is by throwing all of the values into a single, into a single list. And we can use a for loop to go through each item in this 2D matrix, a nested for loop. So for each I being the row and j being the column, we will go through, similar to the other matrix problems above, we go through and fetch the pixel value that's stored at that location, at location row I, column j. And then what we can do is take our list, our empty list, and add the pixel value to that list and just grow the list. And the trick we're using here is to turn that pixel value into a tiny list with a single element, and then use a convention that you can add, fuse two lists together, concatenate two lists using the plus sign. Similarly to how we can add two strings together and just kind of stick them together. Alternatively, you can use this append method here. So if you're interested in that, you can Google it. And then the next step is we want to make the histogram. And this would be something you could Google, for instance, matplotlib, how to make a histogram, and you would see that there's this hist function, and it takes as its input the pixel value, it takes as its input a data set, and then it tries to separate it. And then if you want, you can supply an optional argument here, which is the number of bins, and this is going to be how finely divided the data is. So if we just say 10 bins, it's kind of coarse. If we change that to, say, 50 bins, then we get more fine divisions here. So that's everything. I hope these problems make a bit more sense. I'll see you in the next video.